Okay, I'm going to talk about image processing and OCR and the applications on the iOS platform. So first things first, my name is Thomas Gmelig Meyling, quite a difficult last name. I'm an iOS developer. I work here for 2 years now, a bit over 2 years. Last year I graduated from IT in Leiden, and now I continued studying in Delft, but I still work here. And well, the organization, Sydney introduced this very briefly, but I will introduce us a bit more. We are mobile natives, and well, we have an iOS department, Android department, Q&A, backend, and management, sales. And more about the iOS department, because I guess we're all more interested in that part. We do department meetings, and in those department meetings we define our code conventions and we put them in the style guide, and we really work towards consistency. And the consistency, you see that in the code style guide. We cannot recognize who writes a specific part of code, because it could be anyone. We all write the same kind of code. It's not that one person codes condensed and the other codes very different. And the other part where we are consistent is we work towards reusable libraries that we use in different projects. Okay, so our clients, we're an agency, and we have clients in many different industries, but many of them are airports. And I don't know if any one of you knows what an airport app does, but basically you at your flight and you find the gate where you should go, and where you can navigate around the airport and such kind of things. Okay, so today we talk about image processing and OCR. And the structure, first I will introduce the context. What is this thing? Then I'll talk about what is image processing, the possible applications, so what can you do with it. Then we apply it on an airport case, because we do a lot of stuff for airports. I'll go on the goal, the steps of OCR, and how to use Swift and C++ and this kind of thing, and then a short recap. Okay, so we always watch the Apple keynote, and this one was in September 2014, and they announced the iPhone 6, and it had a better camera. In 2015, iPhone 6s, yet again, it had a better camera. Well, you can see some trend here already, but 2016, iPhone 7, it had a better camera. And of course, the iPhone X, we all love it or hate it, not sure. Yet again, it had a better camera. Also, I couldn't find a figure for iPhone 8 and 10, but the processing performance also is a lot better. And well, that gives us an opportunity. Phones are now suitable for complex image processing tasks. They're more suitable than ever for this kind of applications. That's also why Apple introduced CoreML and Vision. But this work was done, the research we done was done before it was announced. I guess everyone knows you have barcode scanning. Barcodes are used in retail, so every product in the supermarket has a barcode. But you also have QR codes. I think everyone knows them, but this is an example. And if you scan this one, it will actually say example of a QR code. It's embedded in it. And you have optical character recognition. Optical character recognition, if I will take a picture of this on my phone and I wanted the text again, like in a string format, I would have to use OCR. And you usually do it, or they started doing it to save disk space. Images use pixels to save colors for pixels in a matrix. But yeah, a string uses much less space than an image of a string. But it's also, sometimes you write a contract and you want to be able to edit it again. Well, you can use OCR and then edit it again because it's a string, you can do anything with it. But you can also do much other things with it after that. So yeah, can any of you think of some applications of OCR already, or barcode scanning? Either of them? Which, what? Ah, okay, API, okay. Good one. Which one? Ah, okay. And what can you do with OCR? Okay, but, okay. Well, good ones.
There are business calculator. Business calculator just basically the scans business cards and can fill in data like in your contacts.
Yeah, that's also a good one. Well, that's a good example. I didn't have that one, but I've also some examples. You have connecting on social media. This is Facebook Messenger and Snapchat. You can add people with QR codes. So this is not OCR, but barcodes. It's also used for authentication. So you can connect your WhatsApp web or take over your payments from ING from the website to the mobile phone. You can also use it for identification. Well, you can scan your ID card at an airport, and there's a code on the back of it, and you can scan it, and after that they can confirm it's you because the code. Oh, well, barcodes again, they are also used for airport tickets, but you can also use them for tickets for like a concert or that kind of stuff. Payment. This is an IBAN card and a card with like credit card numbers on them, which you use for payment. You have meters. Sometimes an energy company requires the watt meter to be photographed, or so they know your meter stand. And you can use it for your mileage logging. So if you often travel by car, you often need to log your mileage for the government and for your company often. So that's kind of useful application as well. And useful here, you'll probably be like, okay, but I could just write those few numbers down. But you have to often take a picture anyways for sort of proof. So you take the picture anyway, so why not use it for OCR? And real-time translation. This is the Google Translate app. Some of you might know this book, some may not. And well, it translates it to Dutch. It's kind of oddly translated, but it's very cool that it does this in real time in context. So these are things you can do with OCR, but you can do a lot of different things. It's just to give you some kind of feeling with the subject. And other things are like automatic number plate recognition. So you scan the number plate of a car. It's invoice scanning. You get an invoice. You have to pay it. Take a picture. All the info is there. Or scanning products like an API app. You can scan a product. Well, we do a lot for airports. I already told you. Therefore, those things are here. The signs. But what can you do on an airport with OCR that would make it easier? Well, you can scan credit cards. Often you want to order something on the airport, like food or maybe your tickets. You can also scan the flight tickets, not with OCR per se, but with barcode scanning. And you can scan the ID cards for mobile passport control, and it saves you a whole lot of time when checking in. Okay. At Amsterdam, we work towards reusable libraries. And because we have many airport clients for which we make apps, we want this to be reusable as well. We don't want to write our OCR code every time over and over again. So there has to be some, and we also work in different domains. So there needs to be both a domain independent layer and an airport specific layer. And we also want to do all the computations on the device. This is because when people are traveling, say to the United States and they're from the Netherlands, internet might be very expensive. And in airports, you don't even always have a very good connection because the building structure. Also, we use libraries that are available both for iOS and Android, because we also make Android apps, and if it's really good, we want it to be available for Android as well, so that's kind of important. But we program to a Swift interface, so if we use libraries that are not written in Swift, we have to port it. And what we want is make image processing tasks achievable in a few lines of code. So if I want to do OCR, I just want to write extract text or binarize image, and it should work. And I'll come to that later. So why would you do the computation on device? Well, I told you about data cost, but these are the reasons Apple gave us with their Core ML talk as well. People care about their privacy. I don't want my identity card to be sent to some random server when I'm not certain about it. So you want to do many of these things on the device. So what's available already? Well, I downloaded a whole lot of apps, and to see how they worked and what kind of libraries they use. Sometimes they include a license, or not a license, what kind of open source libraries they used. Many of them were proprietary and were very expensive. And we were an agency. We develop an app and we want it to replicate it and make it available for many airports. So this would be, it would be kind of useful to make something for our own. So we started to look into open source libraries. And does any one of you know an open source library for image processing? Or OCR? Which one? I haven't found it, so. Which one? Oh yeah, that's a good one. Yeah, nice. Okay. Yeah, okay, great. Well, we used OpenCV, and it's a bundle. It's written in C++. It's a bundle of utilities for OpenCV stands for computer vision, open computer vision, and it's a bundle of all kinds of utilities you might need when you want to do computer vision. So it contains a lot. It was initially released in 2000, and we use it for canny edge detection, contours, adaptive thresholding, blur, and perspective transform. Might not tell, those words might be a bit of buzzwords, but this is canny edge detection, and you use it in OCR. I will come to that. And adaptive thresholding is like, say you have an image, a grayscale image, you have some point of contrast, and you just threshold that, and everything above the threshold is white, and everything below it is black. Perspective transform is some kind of transformation to change the perspective of an image, and I will get more in depth about that. We also use Tesseract indeed. It's kind of funny. It's actually it's a classification system, and if you have a prepared image, so an image with black letters on white or white letters on black, you put it into Tesseract, and it will give you the text that's contained in it. You can train it yourself. It uses machine learning, but it's very funny because it's very old, and there's nothing better yet. Or well, there are some other OCR things, but it's still kind of a good, it's still very good, and it's almost 30 years old, or what is it? It's very old. But the problem with this is, it's garbage in, garbage out. So if you have a bad image, you will get completely garbage and random characters, and you cannot do anything with it. Also for the barcodes, not for OCR, you have zebra crossing. It says ZXing, but you pronounce it as zebra crossing. It works out of the box, but it's Objective-C, so we still have to port it. But it works very well out of the box, and you shouldn't have to configure much for that. So we get to this architecture. So in the top level, there's image processing, and we prefix our libraries with M2 for M2Mobi. And image processing contains all the things that's used in below. So it contains a camera component that makes it very easy to have a camera view controller and just take a picture or scan things. And barcode kit basically only includes zebra crossing, and it works pretty well. There was not much to that, but you can still replace this very easily with another library. So therefore, this still has, this is still very useful. So we could use native iOS barcode scanning here without changing all the apps below it. We also have OCR kit, and it uses image processing and therefore OpenCV, but it also uses Tesseract-OCR, and there's some more stuff in there that prepares an image for OCR. And below that there's a specific, this is for a specific domain. So we have an airport kit, and there could be like there's a proof of concept, but there could be 4 airport apps below here, like Dubai, DFW, MCO, and there could be any of them. And we wouldn't have to change the airport kit and rewrite the code. So barcode scanning. Okay, so let's say we're on the airport. I have this ticket in my wallet. I load it in the app via a screenshot or via the sharing component in the wallet. It will extract this information. This is what Airport Kit will extract from the flight. This date, it might look very weird to you. It's like a military standard. They use it at airports, but it's basically the 7th day of the year. So it is well. And the flight number, this is a from IATA, so the code from the airport where the plane leaves, and the to airport where the plane will arrive. And basically all this information is what we need to show to find a flight in the app. And you will then see the flight dashboard, and you can see information like, okay, I have to go to gate E28. So, okay, well, barcode scanning was not that difficult. So let's say we are at the gate, we arrived at the gate, we want to order food. This is the DFW app we've created, and this is already in it. And, well, say we want to eat Riata Grill because they have mobile ordering. We don't want tomatoes, and we want to check out. Yet you have to fill in all the payment information yourself for your credit card, for instance. But you could also do this with OCR. So, yeah, of course, if you want to do it with OCR, the user has to take a picture. So, well, what you ask the user somewhere to create a picture, and they will probably have the card either on a desk or something, and take a picture like from some kind of angle, or they will take a picture from their end holding the card. And the user might come with a photo like this. But we put this into Tesseract, and the output was completely garbage. So there's something wrong with the image. We cannot use this. So what's wrong with this picture? Can you guys come up with? Sorry?
The whites are not very clear, so you can identify the digits.
Yeah, true.
And also with the background doesn't help either, even if the text is working properly.
Yes, and it's perspective, and it's rotated. So there's pretty much wrong with this picture, but it's very likely that the user will come up with this picture. So That's a kind of struggle you have to deal with. You cannot ask the user, like, take a picture in very bright light from a very right perspective. That won't work. So you have to deal with this problem. And well, the first thing you can do, there's scaling, rotation, deskewing, and border removal. We did this for now with pinpoints, which is not the best user experience. And but yeah, it does a great amount of steps for you, and it changes the perspective, and it's cropped, and it doesn't contain the borders anymore. But now with iOS 11, you could also use vision to detect text, and then after that, use that input to do this computation. But we use these pinpoints, and you then get this kind of output. But there's still much wrong with this picture, because you have the light here that kind of makes the numbers that are white hard to see. You have many different colors, and we need a black and white input. And yeah, that's basically what's wrong. So you need a binarization algorithm. Binarization is a word for binary digits 1 and 0. You want two colors, either black or white, 1 or 0, or well, 0 or 1. And you have many different binarization algorithms, but none of these, the Tesseract or something doesn't contain this. OpenCV, you can use adaptive threshold, but it will still not deal with the colors. So you need an algorithm. We implemented CocoaHeads. To show you an example, these are different binarization algorithms, and this one is CocoaHeads, and it works with, yeah, you extract it. Well, it looks at the height and the width of characters, of edges, and then it kind of decides if it might be a character or not. So it's like the aspect ratio and edges, but it's a very slow algorithm. So if you're going to scan, like for instance, a white paper with black text, you don't want to use it because it will be very slow, and this one will probably just work as well. Yeah, just as good. So but we use CocoaHeads, and for small pieces of text like a credit card, it works very well, and it extracts the text very good, as you can see. And then you use the character classification. Well, we use Tesseract-OCR, and it basically, because you give a good input, you get a good output. And well, this is now something we can start an order with, But what's kind of funny is many people have touched OCR, and many people think that Tesseract is like bad, and I tried Tesseract, it gave me very bad output. But our conclusion is you should just prepare the image very well, and you really don't need custom classification. People often tend to over-engineer and want to reinvent the wheel, but we didn't need to, and I don't think you need either. So yeah, the steps prior to the text extraction are the most important. And yeah, I think Tesseract out of the box works with many languages like Arabic and stuff, and you can even train custom fonts. So it's not very likely that you need something different. So what to do after image processing? Well, in this case, because it's mobile ordering, you probably want to submit the credit card information to your payment provider, and the user probably still has to fill in the security code and then do a payment. But for instance, in the mileage tracking app, the example I gave, where you scan your car's mileage, you may want to submit the original image and the mileage to a server, and then add it to your saved trips. But it really depends on your use case what you want to do next. But you can basically do anything you can do with string text here. Okay, but the difficult thing is we used OpenCV and it's C++. And I don't know if any one of you have bridged C++ in Swift projects. It's kind of a hell. Okay, so bridging C++, it's kind of a workaround you have to do. Because the problem is, Swift, it's like we're all here. I personally, my native language is Dutch, but many of you maybe have a different native language, but we all speak English. Well, the same is with Swift, C++, and Objective-C. They all speak Objective-C, but they don't speak. Swift doesn't speak C++, so we have to kind of think of a workaround here. And the neat thing Objective-C gives us, I assume you're all familiar somewhat with Objective-C. They have, I've written an extension, but it's a category effect. You can use Objective-C extensions to include the C++. So you get, this is normal bridging. You have a .h file which you can use in Swift, and the implementation is written in a .m file. So the public interface is known to Swift, and the implementation is kind of, is embedded in there. But what we do different, we basically add a category to the class, or to the class you want to use C++ in, and then you can you can use OpenCV or your image processing things. So what does Objective-C++ even look like? Oh wait, sorry. To illustrate it a bit better, it's not completely valid in UML, but it serves the purpose. So UI image, we all know UI image. It's Objective-C or Swift. You don't have to put it in the category because it's Objective-C. But warp with points, we use OpenCV to do the perspective transformation. And it's written in C++. So we define it in a public header, which is C, or Objective-C. But we actually implement it in the .mm file, so the Objective-C++. And I really wouldn't say that you should program Objective-C++ because it's really, you really just mix two languages. And you can see this, if you know Objective-C, you will see that I'm calling a method here on self. But std factor is C++ again, and contour is a type def that uses a C++ type. So it's really just a mix of the two languages, and it's really difficult. And you should not want to use this in your project. But what we've now done in the actual Swift file, we now only write image processing, and we init it, and we can just use a few statements and then get a proper output. And you can do anything with it from here. So this is what we now this is what we do in actual Swift projects. So what we've actually achieved is that all the computations are done on the device. It's portable to Android, and client apps are only 100% in Swift. So are there questions?
Yeah, is it not possible just to use train Tesseract model in CoreML?
I have not used it. It was not available. CoreML was not available when we developed this, but it should be available, or it should be possible. But we have not done it, and we also, our clients' apps need to be available to iOS 9 and iOS 10. So CoreML isn't really available to us yet, but you should be able to use it if someone ports the model with Python, with the Python app from Apple that they supply for CoreML, and you should be able to port it to CoreML. But I have not done it personally. Yes.
Why did you decide not to use the Apple Vision? You said in one of the slides.
Well, we developed it before it, and the availability for iOS 9 and iOS 10 apps. But yeah, so
It is in iOS 10. It's in 10 and 11, or just 11.
I personally thought it was 11,
Okay.
but we still support iOS 9 even. So we need like at least 95 market share, I think, or maybe 99. So it takes pretty long before we can drop iOS versions.
May I think? Can I have another follow-up question on this subject? How difficult is it to, or maybe not difficult, how do you see this that you're still supporting availability for iOS 9? How do you go about it?
How we measure it.
For development, because you know.
But what do you mean? How we measure our
Is it difficult, personally as a programmer, you know, as a developer, you know, to be to maintain compatibility with the older iOS? Because would you, you know, maybe developers have a tendency to, you know, to use the latest technology, but you have to support them if they have a huge, you know, older.
Yeah, I think.
How does it make you feel?
Well, if you don't use it in other projects, you don't miss it, I would say. So it makes life easier, and many things like in iOS 9, we love this UI stack view. And when it came out, we kind of think it was, it sucked that we didn't have it in iOS 8 and we had to support iOS 8. Sometimes even 7, but I think 8 was the biggest problem. And we used the port there, so we used OA stack view, which is publicly available, it's open source. And yeah, it's the same, basically the same as here. Here we used other technologies that are open source available. So, of course, iOS 11 Vision is very good, but you can still achieve the same. It does, yeah.
Did you experiment with the other stuff, or do you right away not go? Is it a decision not to go for the new technology because you need to support all the platforms, or do you also get experiments? You know, like
Well, I have checked iOS 11 Vision SDK, and out of the box it only has text recognition, as in it knows where text is, but it doesn't OCR. It doesn't do OCR. So that's also why people ask for, like, is there a CoreML model to actually classify characters and convert it to computer text? But you can now, out of the box, you can only use it to, it would only put squares around this. So to say like, yeah, here's a character, okay, nice. And you can still use, even with Tesseract, you can use that, use that to tell you where characters are, and then use Tesseract to do the actual conversion, or like if the squares would be like this, you know that it would be skewed. So you can do the perspective transform based on Apple's Vision output. So you can still use it. It really just complements each other at the moment. So I don't think you should not use. You can still use Vision and use Tesseract, because at the moment it doesn't do as OCR. Okay. Anyone else? Oh yeah. Oh, sorry. At which? No.
You didn't see it?
What?
When you started, when I went into Tesseract, it was always like, what you use Tesseract, you use the Atomica for image preparation.
Yeah, I've looked at the way we already used OCR in some apps, and I've looked how we done it there, and I personally still I still had experienced problems with like an output like this or an image like this. It would still give many problems because this is basically a rainbow, and it is very hard to actually convert to proper input, because you have the light, you have the many colors, white on white, white text on white, yeah, white, what do you call it, reflection. So we really think we really needed a different binarization algorithm, and others are more like contrast things. They add a bit contrast. They're not very good, I think, or at least that was my experience. Anyone? Yeah.
Yeah, Swift-OCR is kind of more lightweight than Tesseract.
Yeah, I've looked into Swift-OCR as well. Go back to the questions. I've looked into Swift-OCR, and yeah, it's also why when we were at the architecture, we had Tesseract-OCR above, like M2OCR kit. We can still change the actual classification system, and it's very loosely coupled at the moment. So we only use Tesseract for classification, and we can really easily swap another engine in. And yeah, we mainly focused on doing the steps before OCR different than before.
But how does it compare to Tesseract if you try to compare them with vision, like with all those boxes around letters?
Yeah, I didn't use the Swift-OCR with vision, but well, yeah, I'm pretty sure it's there. I'm pretty sure that if you use Swift-OCR or Tesseract, I think they're both like, I think Swift-OCR is even better out of the box maybe. But you still will need the binarization with the input I showed you. You still will need to warp it. So it's basically only the classification. But yeah, you can use it.
And that Hauser algorithm, it is provided by which library? By OpenCV or?
Which one?
What you mentioned, the binarization algorithm for?
Well, there's no algorithm that's open source that you can use out of the box. You have
So
to.
you had to write it yourself?
Yeah, I've written it myself. Yeah.
Wow.
Yeah. So there are some things that many that are available, but this one was not available open source. And there was an implementation in Java and Python, which you can use for reference, and it's not too much code, but you have to write it yourself at the moment. So that's why we put it in a library. Is there any more questions? Oh yeah.
You said that the Quasar algorithm is pretty slow, but how long does it actually take to scan?
Well, at the moment, it's also funny. At first it took hours, but I've done something wrong. But now, a debit card actually takes a few seconds. Or no, sorry, it doesn't even take seconds. It's pretty instant, so that doesn't take any time. But I think if you take like a wall letter paper and scan it, it takes longer. But it also depends on what input you give it. Because if the way it works, it will detect edges, and on these edges it will do all the computations to see if it's a character or not. But if there's like many different colors or many things where there's contrast, it might look at many things and it will see, oh, it's not a character, but it will look at everything. So it will loop over it and be like, oh, well, it's not a character, but it takes time. So the better or the less difficult your input is, the shorter it takes. But I wouldn't recommend using it for very large amount of text if it's black and white already. And yeah. And yeah.
You said it's portable to Android. Can you give me a bit of an insight? How is it working? Or is it
Well, portable to Android. With that I mean we only use things that are available on both platforms. So OpenCV, there's a Java OpenCV, and you can use that. I think Tesseract has a Java API as well. And zebra crossing, yeah, originally even was in Java, so you can use that. But we wanted to, we didn't want to use other public open source repositories that didn't exist for Android, because what's great about OpenCV and Java and OpenCV C++, the functions are very similar. So you see, oh, here we use blah 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 edge detection, kenny edge detection. You can literally see, oh, the parameter is 1, 2, okay, and do exactly the same in Android. Whereas if you use a completely different library, you would have to do very many things. You would have to look like, oh, what does this do? And then look into the SDK and in the specification and see, oh, well, I don't see something similar, or yeah. So you would have to put much more time importing it. More questions?